Guys, welcome to the Helmholtz equation and AGX. Today video we're gonna explain uh, the three concepts: speed versus velocity, free body diagram, and Newton's law acceleration. So we're gonna get started. We're in episode 2 of our series where I left off. Welcome to Beyond the Equation. So the first thing we're gonna know is we're gonna know the force acting on a rocket. So we have three main forces acting on a rocket. This is a rocket, but in engineering or physics uh, we don't draw the rocket, just we draw a box and put arrows represent the direction of a force. We called it a free body diagram. So here we have the three forces. We have the thrust force and we have the weight and drag force. Thrust force is if the force produced by the engine, it's getting out here. Let's see, getting, for example, here from the nozzle, like that. For example, that is the thrust, like getting. And this force push the rocket, push the rocket, push the rocket up in this direction. Push the rocket up because it's going down and it's going down and it's push it up. According to Newton, third law, every action has an equal and opposite reaction because it's the gases produced by the rocket or the thrust is going down, the rocket gonna go up because it's let's see because yeah I think you understand it according to Newton's law. The next one, the other forces we have the weight force. It's the weight produced by the mass of the rocket. It's the mass multiplied by the gravitational force. This is it. Drag force is the force produced by the air. We have the two types of drag. That's not important, but the drag, when imagine you're holding like a block and running through the air, it's gonna be harder. That's drag force because the air molecules is colliding with you and slow you down. Like it's like I'm pushing you. The same thing when you run and I push you. That's so close to stuff. That's why in a rocket we put like the shapes are like here we have triangle and here triangle that reduce like the air resistance. It's cut through the air instead of colliding with it. That's it. It's a three rocket I explained. Why I add weight plus drag? Because they are in the same direction, and when we have two forces or multiple forces in the same direction, we add them up. We add the value up because they are in the same direction. So how we gonna know if this rocket gonna fly or gonna stay on a launch pad or gonna accelerate or have velocity or something? If the thrust force, this force produced by the engine is bigger than the drag plus weight, it's gonna will fly and will accelerate because it's bigger. And if the thrust is smaller than the drag plus the weight, it's gonna stay on the launch pad because the engine is producing less force than it's need to fly. And the third one, we have if thrust equals the drag plus weight, a rocket gonna fly but won't accelerate. The velocity gonna be stay constant. It's not gonna change or increase with time. So let's go to the second. We here have I mentioned velocity, but I didn't explain what's velocity and what's speed. Speed, all we know speed is how fast the object is moving per second. Velocity is so close for it, but the difference velocity have an attitude, have a direction. If you notice here, the box is moving 5 meters per second to the left in this direction, to the right. But this box doesn't move. It just have a value. It's 5 meters. We don't know it's moving up, down, left, or right. But this box is, we know it's moving to the left by 5 meters per second. This is velocity. It's just the speed, but has an attitude, has a direction. Here we have the law of velocity. V equals d over t, a distance over time. Velocity, meter per second, distance, and meters and times. Can calculate, I think we can calculate distance if we have velocity and time, and we can calculate uh, time if we have velocity and what this mean? This means velocity equals cha change in position. Let's say it's d over time. So for example, it's here, then it's gonna change to be here in this. So every 5 meters, it's gonna change the position. First, it's gonna be here, then it's gonna move by 5 meters. The box gonna be here, for example, if the distance here is 5 meters. This is velocity, and so simple concept, but so important. So next we're gonna move to acceleration. What's the difference between acceleration and velocity? So velocity is how much the object, how fast the object is moving per second. This car move at 5 meters per second. This car move at 5 meters per second square. So what's acceleration? Acceleration is a change in velocity here, if you have see. It's change in velocity and change in time. This is acceleration. It's how much the velocity change per second. So for example, in this table, first the velocity, the time was zero, the acceleration was zero, velocity was zero. When the time is 5, acceleration is 5, and here the acceleration is constant. So when the time uh, we multiply acceleration by time to get velocity. So when the time increase, the velocity change. Sorry, if you don't, let's wait a minute. How can I explain this? Sorry, guys. Okay, so let's return. We said acceleration is a change in velocity. That's right. Acceleration is change in velocity over time. It's how much the acceleration change per second. So here, if the acceleration is 5, here is just in the first second, okay, the velocity gonna be 5. In the second, it's gonna be 10. So it's increased by 5 every second. The velocity increase because the acceleration is increasing in velocity and the acceleration is decreasing on velocity. It's gonna be 10, then 50, 20, 25, 30, 35, 40 meters per second at uh, when time is 8. So that's velocity and that's acceleration. Velocity, it's change the position over time. Acceleration, it's change the velocity over time. We move to the second concept, which with the fifth, which is Newton's second law. Newton's second law, let's say, the bigger the mass, the bigger force need to accelerate it. So, uh, if I have a two object, let's say I have, let's explain it first. This is how we represent it mathematically. F equals ma. F is the force in, and m is the mass by kilogram. A acceleration is meter per second squared. So that's it, Newton. I'm gonna explain it. Let's go to this example. Here we have calculation acceleration. How difference in mass affect acceleration. So if you notice, we said the heavier the object needs a bigger force to accelerate in motion second law. So here we have an object. The mass of it is 5. The F is 10, and we don't know the acceleration. Here we have the mass is 1 kilogram, the acceleration is 10, and the force is 10, and the acceleration we don't know. So here we can start the first score, which is the score. If you notice first, the forces, the F is the same in blue and it is the same, and the chords are the same. Okay, so the first one, when I calculate the acceleration, it's A equals F over m. A is 10 over 10 divided by 5, which is 2 meters per second squared. Second curve gonna be 10 meters per second squared. Why? Because it have a smaller mass, so with the same force, it's gonna accelerate more according to Newton's second law. This is the video for today, guys. Thank you, and see you in the next episode. We're gonna learn about we're gonna learn how to calculate forces and uh, according on a rocket until we're gonna build our DIY rocket and we're gonna calculate how fast it's gonna go. So stick to this series, you're gonna learn a lot. See you later in next episode.